lecture, because we have a brand new concept that just requires you to listen. Unless you had Math 3 honors, then of course we graph, sine, and cosine, and tangent, and then maybe the other three. Well, that's what our next chapter is, graphing. Input, say it. I put, ooh, first hour, yes. Got some words there. All right, and I didn't draw, and I can't draw in this Microsoft Word document. I didn't give you a 30, 60, 90. You should have drawn that real quick with the 1, root 3, 2 sides. And then in order to evaluate this input, say it, output, sine of x equals y. X is the angle measure, so that's why we have a chart here. All right, and we're going to whittle this down. This is not how you're going to graph for the rest of the time. We do input-output to get a generalization of the picture, and then we synthesize it and get the attributes. All right, and that's why, when we did this with our book back in last semester, let's say, we did input-output at all the ones that you were supposed to know, like 8 of the pictures. That's what I made you do. The pictures were blank, and you had to fill them in by input-output and then get the picture. So that's today's thing. Then we're going to get the attributes. So sine of, and I'm going to go to my notes now. This is where you want to open up your notes. Oh, no, I hope this transferred. So we're going with a new computer, and if this didn't transfer, then the movie is over, because then I'm going to get very, very, very sad. But I did start a, oh, right, it's there. The internet's an amazing thing. Okay, so here's what we had for sine. This is where you want to start with, and this is the attributes you want to glean from. For those that finished that, I don't have all day to get through that thing. I did ask in the beginning, what's sine of 0? And everyone's looking at me like I'm an alien when they had to answer that question on yesterday's test, probably. But anyway, that's me complaining. Y equals sine of x. The key components, and I'm going to give you like both sides. I'm going to try to show you what you should have wrote on the left side, which the ones that won the contest of getting this graphed well did do that. The key components will end up being the big 4. Then I could talk about 2, 3, 4. And I'm going to zoom in on this. And what those are for right now, I'm going to put what we just graphed. And what we graphed was from 0 to 2 pi. Then I'm going to change it. I'm going to show you. This is the parent graph, by the way. Did I put that up here? Parent function, key components. Parent, y equals sine of x. Then we're going to talk about changes right away that can happen to it. But that's what happened here. And we started with sine of 0, and sine of 0 was 0. And if you didn't get that far, you're severely, anyone? Behind. Now, the next key components are, let's cut 2 pi into fourths. So cut 2 pi in half, and that's pi. And then cut pi in half, and that's pi over 2. And then, okay, you get ready for this, because the only people that screw this up are ones that are fractionally, anyone? Challenged. 1 pi over 2. 2 pi over 2. What's next? 3 pi over 2. What's next? 4 pi over 2. So this one's 3 pi over 2. Now, for those that completed your chart, what is the sine of pi over 2? What do we get for the sine of pi over 2? Oh, no. Waiting too long. 1. What's the sine of pi? 0. What's the sine of 3 pi over 2? Negative 1. And then what's the sine of 2 pi? Now, what I skipped, I'm going to write these but then erase them, was, excuse me, pi over 6, pi over 4, and pi over 3. But what I just wanted you to understand is those 3 values, the sine of pi over 2 was like root 2 over 2, which is approximately 0.7. Wrong. I'm sorry. Wrong. I did that wrong. Sine of pi over 6 is first, and that's a half. Sine of pi over 4 was root 2 over 2, which is 0.7. Sine of pi over 3 was root 3 over 2, which is like approximately 0.8. So what you can guarantee is that's the connection from that point to that point. Because there's actually an infinite amount of angles between 0 and pi over 2. That's what graphing is. It's not just these 4 key or 5 key points that I've done. We're going to do the 5 key points and connect them, and then that takes care of all of these angle measures in the middle. What's the sign of those? So basically, the sign of close to 0 is close to 0 as an output. And because we've outputted all year long, this language should not be like a different language, what I'm talking about right now. It really should not. And that's what sometimes the problem is. I really try to build on stuff that we've done from before so that your understanding can continue. Okay, so you're going to find out that that's really all we're going to want to know. What are those key 5 components? Oh boy, I'm not graphing really well right now. Connect those dots with a smooth curve. Everyone say hello to the sine curve. Hello, sine curve. All right, and then you know what goes on the other side because we are going to do this? What do you think's over here? What do you think I'm going to put over there as an x value? What? Negative 2 pi. And then what do you think I'm going to put right here? Negative pi. What do you think I'm going to put right here? Really, no one's saying anything. Negative pi over 2, and then what do you think is going to go right here? Do I have enough time for all this? Yeah, I don't care if this goes to the end. You need to focus. This is the critical key day. All right, and those that are absent, that didn't tell me. One wrestling away for our didn't tell me. And then the others that are at what's the thing going on today? They're at yeah. And then they come back, I missed. And I go, it's a school function. You're supposed to, and then these people that don't do anything. This is the rant, GA, that I went with my discrete students. How they do nothing and expect everything. Oh, that drives me crazy. Anyway, you're here. You shouldn't have to listen to this. I'm sorry. SV. All right. Isn't this cool that we're getting, all right. Okay, so what sign of negative, do you know negative pi over 2 is coterminal with 3 pi over 2? So what's the sign of negative 3 pi over 2? Negative, anyone? 1. It should be the same as this value right here. All right? And then negative pi is the same as pi. Negative 3 pi over 2 is coterminal with pi over 2. And then negative 2 pi is, of course, coterminal with positive 2 pi. I'm really disappointed in my graphing abilities today. And then cosine, I'm going quicker, all right? And it's based off of, where's that Word document? Then I had them, and someone won the contest for this, graphing cosine in the same way and filling out the chart values. And then all the dots all the way around. By the way, on this thing, if you want to complete it later, the taller lines are like all the over 4s. But really, this tall line, this 1, 2, 3, this 4th line I'm looking at right here, that's supposed to be pi over 2, all right? But this one's pi over 4. And you know, you really should go through that process to get a little understanding of why the cosine is going to look like this. Y equals cosine. This is the parent. And then we're going to make babies. Aw, cute little cosine curves. All right. Oh, boy. Okay. Oh, geez. I went off the line. Okay, what was the cosine of 0? This makes me sad if you don't answer this real quick, especially when I've seen everyone that did this. Cosine of 0 is 1. That's a different start. All right, and then we're going to get the 4 key components. So why'd you have me graph all that other stuff? Understanding. Input, say it. It's better to understand what something is as opposed to what are the rules to graph it. I just want to know the rules so I can get the picture. What's the cosine of pi over 2 in those that finished this? What'd you get? 0. And if you didn't get these things and you couldn't figure them out, it's not actually the greatest thing. We're behind, right? And I don't know. So you're lacking in the understanding of what we're doing here. What's the cosine of pi? Negative 1, then 0, then 1. And then if you remember when we did our book, I said, remember, sine is 2 bowls. And remember, cosine is the cosine, anyone? I hate that graph. Cosine is anyone? The cosine, anyone? What? The cosine kid. From what movie does that come from? The Karate Kid, the crane at the end. Not the new crappy version. I'm talking about the old original that's awesome. Okay? All right. Negative 2 pi. Negative pi. Negative pi over 2, Man, it's creepy in here, isn't it? Our heater in the back's making like spooky noises. I'm freaking out, man. Anyone need the bear? Okay. Teddy Ruxpin used to be able to talk. Does anyone know what that is at all? That's a really old reference. Oh my gosh. It's just really the screen. I really wanted to teach on the new computer, but wasn't able to today. Okay, so here's the key though. I just graphed two periods. You really want to focus on that. Wah! Cosine is the cosine kid. I like thinking of sine as two bowls. One bowl upside down, and then one bowl right side up, and that's how it finishes. Bowl connected together. And those are what all of them will look like, but then there's going to be changes. Okay, and the changes are called, here's two words, and then you can put this down, ways the parent functions will be affected. They're going to be stretched or squeezed or shrunk, I guess, vertically and horizontally. And those two things are called something specific in trig. This first part is just to give the book props, that you could just read the book. They do it in the shortest possible, most direct and awesome way of explaining things. Don't write this down. You can read this later. I'm just, again, giving you props. Can everyone say the word amplitude? Not giving you props. I'm giving the book props, sorry. I'll give those props when we do our little ceremony, which will be tomorrow. Those are props. Can everyone say amplitude? Did we already do that? I'm sorry. Okay, amplitude is a vertical stretching and shrinking. It's going to be one of the easiest things that you will see. So if you want to write that down, go ahead. Don't write all of this sentence down, but maybe you could do a real quick sketch of our parent, which is the red graph, compared to y equals 2 sine x. And it's really a simple idea. And actually, I'll move in on this. It really is, okay, just answer the question. What's sine of pi over 2? Oh, we should know that answer. What's sine of pi over 2? What's sine of pi over 2? 1. Then what happens when you take 1 and multiply it by 2? What does that become? 2! So now instead of having this point, if I had 2 sine x, it just gets stretched up to 2. But then don't overthink it. What's sine of 0 still? Whoops, what? Sine of 0 is still what? 0. What's 0 times 2? Still 0. So this point stays anchored where it's at. Everything else just gets stretched. And that's the simplest thing you could possibly see in this situation as far as order of operations and why does this happen. That is called amplitude. And then maybe you want to make a note and real quick draw that 2 sine x just so you have the idea and understand that the range has changed. I forgot to put this up for sine and cosine. If you don't mind, you can go back up to your notes real quick. Some things you should know about both of them. The domain is all real numbers for both of them. The range of the parents is only from 1 to -1, and I should say -1 to 1. Use the proper order. Notice the brackets. But when you change the amplitude, you change the range. Okay? Then there's other attributes that we'll discover later. Those are the key ones, though. So when you change the amplitude, you change the range. And it also changes the low point. I do want you to write one thing down. I'm sorry this is really a key definition. Oh, that's good. This is a key definition you want to understand. The amplitude of the periodic function is half the difference between the max and the minimum values. So you will say that the amplitude for this is 2 for this 2 sine x. Notice it goes from 2 to -2, which covers a distance of 4 y values, right? That's 4 spaces. Okay, so amplitude is always considered half of the total y distance covered. This is 4 units covered by this graph. Because when we start shifting up and down, then the amplitude gets a little bit crazy. What is the amplitude kind of thing? I'll press pause as we have a hand up in the air. Don't write this whole, okay, as in conclusion, the amplitude is the a value in front of the function. But just make sure a is always stated as a positive, because in what amplitude is considered a distance. So a must always be, I'll write this really slow, stated as a positive number, because it's a distance. Because it's a distance. So I don't care if there's a negative in front. Do you know what a negative in front of a function does, by the way? This is coming up. It just flips it over the x-axis. It has nothing to do with the amplitude. Right? Just make sure you understand that. All right. Now this one's going to have to be just a formula. And, you know, when I over-explain, I try to show you why, and I will probably talk about it as we actually graph it. You're just going to have to know this. The period of the parent function's 2 pi. The period of baby functions related to this will look like this, and I pick sine. Sine of number x, number on the inside of the function. That is b, and that will change the period to 2 pi over b, whatever that number is. And that will be the last number on the x-axis where the sine curve completes itself. And you're going to see that coming up here. Don't write all the rest of this. You can read this on your own. I'm not going to give you the time. When you go to college, you're going to have to do a lot of reading. All right. I don't know if you want to write this one. In fact, don't. Okay? But I do want you to see how this affects it. And then this is what our notes are all going to be based off of. But again, we just picked 2 because it's a nice number. But now it's on the inside of the function. So look over here on my notes. What that does is it changes the period to 2 pi over 2, which is pi. Should have picked something different than red there. And that means at a distance of pi, one sine curve completes itself. Bowl, then bowl. Bowl, bowl. All right? And then this is where we're only going to have a problem with graphing sine and cosine if we're fractionally challenged. Because what you're going to have to do is break that period down into 4 parts, and it's all fractions, and I'll show you how easy that it's actually going to be. So go ahead and take a minute to write something down. We got to move on. I'm actually probably a little short on some stuff here. I probably won't get to the last examples, but this is what I will definitely do, I'm thinking. And probably with all the classes. Even though I have a hard time getting first hour started. It's not your fault, it's mine. They may get it done or not. But do as much as you can in the homework, and then I'll show you which questions we'll wait for till tomorrow. But if you can get them done on your own, you're way ahead of the class. Hey, by the way, as you're writing stuff down, do you notice how many sine curves are completed from 0 to 2 pi? How many sine curves how many cycles is what this is called? No, from 0 to 2 pi, how many sine cycles are completed? 1, 2. That's another meaning of this number. It will actually complete 2 complete sine curves from 0 to 2 pi. That's why it's shrunk horizontally. So 2 ways of looking at it. I'll show you what you're responsible for. Okay? All right. Pause. Let's move on. Let's do a couple easy graphs. This is what they say about the period. And it is basically a formula that you want to... why does that keep happening? It's so frustrating. I hit it and then it doesn't register. I hope the new computer's better with that. Period equals 2 pi over b. And then just like in the Get Triggy With It video, these two can be switched, and it's sometimes nice to know that b equals 2 pi over the period. And then we're going to use that on the question I probably won't be able to finish. You know what I'm going to do? When the bell rings and you walk out the door, I'm going to sit in here like a moron and talk to myself to the computer and finish the notes. And then you guys can maybe look at the last 3 minutes of those examples, and then I'll see how many views I get. It's so sad. And that's why I had to yell at my discrete class. How many people do nothing and expect everything? Well, I didn't have the time, 3 minutes, to watch the video today. Ah! All right, here we go. He's such a mean teacher. No, he's not. He's going crazy about lack of effort, but then expecting A's. Okay. You know what this says here for the directions? Graph. And where are we going to graph? We're going to graph this one from negative 2 pi to 2 pi, and that's exactly what I showed you in the parent functions. Okay, but I'm going to go to the right side first and then cut and paste and go to the left. Oh my gosh, I cannot believe I said cut and paste. Did anyone hear that the person that created cut, paste, copy died yesterday or today? Yesterday? I gotta give him props. It's actually something I heard on the radio, and I gotta find out his name. Darn it! It's an amazing. This guy was amazing. Worked for many of the big companies. Worked for Apple for like 17 years. The cut, paste, copy feature used on documents, music, people making music. The guy in the radio said that. It was awesome. Hey, by the way, what's the amplitude? I don't have time for these stories, Mr. S. 3. You know what you have to do? You just got to put 3 and negative 3 on your axis here. We know what the differences look at. It doesn't go as high as 1 and negative 1. It's 3 and negative 3 now. Okay, next thing. You know what the period is? Well, what number do you see right here? Nothing. But what is it? 1. So the period is 2 pi over 1, which is what? 2 pi. So this is an easy one. This is how you break these down. What's half of 2 pi? No time for this. Pi. Half of pi. Now listen to this, and this is going to take those that get severely behind and lag behind. 1 pi over 2. 2 pi over 2. What's next? 3 pi over 2. And then what's last? 4 pi over 2 is a discount double check. And then what's sign do? What sign of 0 still? No time, 0. What sign of pi over 2? Not 1 now, it's what? 3. What sign of pi? 0. Here's what you need to know. Oh, signs the bowls. So it starts at 0, goes to the high point, comes back down to the 0, goes to the low point, and then ends at 0 like that. There's my sine 2 bowls. That's all you got to do. And then, what's this? Oh no, negative 2 pi. This is why this is easy. When they ask me these directions, it's simple. And then common errors, people do this. They go back up to the high point, and then they flash this like that. Is that what happens, yes or no? No, because negative pi over 2 is coterminal with 3 pi over 2. So whatever the sign of 3 pi over 2 is, that's what the sign of negative pi over 2 is. And then you keep going with another sign cycle. All right? Oh, come on. The old hand hitting the screen. And all right. Leaving that up there, same directions. Yeah, here we go. Y equals 4. This is crazy. Sine negative x. Oh no, we got a question and we're running out of time. Okay. All right. Hey, real quick, do you remember what this does to a graph when you have a negative on the inside of the function? I heard most of you say it. It is a y-axis reflection. So it's y-axis. First hour, you might have to watch a little bit more as we get going. I really don't have time for questions at this point because I'm just going to go and we're going to get it moving. Hey, the 4 is easy. Oh, that's an arrow. Okay, 4. Now, why is this going to look just like the other one before? We can always mess with scale, but you do understand that the graph to the right is higher than the graph to the left. Got it? Covers a distance of 8 y values. But now we got to be careful. And the period is still 2 pi because, and it's not negative 2 pi, no. It's just 2 pi over b. Just use the b as 1, but count the negative as a y-axis reflection. Okay, and we'll account for that. But this doesn't change this. Okay, so here we go. 2 pi. Run out of time, Mr. S. Pi over 2. and 3 pi over 2 because the period didn't change from the last question. So those are the 4 critical key components we're going to graph. We're not going to do what we did. I'm going to say this one more time because I get robots that check out after 5 minutes of the notes. You're not going to do all of these values. This was just an idea to get you to understand how the points connect. Okay? All right. What sign of 0 still? 0, no time. And it gets reflected over the y-axis. Does that change anything? No. Okay, what sign of pi over 2? It's what? 1, or 4 now in this case, but what happens to that? It gets what? Reflected over the y-axis, so that point gets thrown over here. And then what's the sign of, I know I'm confusing here, but originally the sign of negative pi over 2 is negative 4, but that gets reflected over the y-axis, and now we're actually down here. So actually when I graph this, you should see this as a flipped graph compared to the one I have on the left. All right? So back to 0, high point. All right? And then this one, going negative pi over 2 to or 2 pi to negative 2 pi. Negative pi and negative 3 pi over 2. This completes these values. So all you got to remember is the bowls. And I did sine again. I should have done cosine. I haven't done an example of that. Okay, some people are packing up. It's because there's 3 minutes left and they got to be ready to sprint out the door as fast as possible. All right, so I'm going to keep going. You're ready, aren't you? Just don't knock anyone over, okay? All right, here's what these directions say. Graph a 2-period interval. All right, here we go as you put your stuff away. All right, y equals, I'm going to put a 2 there to put the stuff that we had from before, but now we have the one that you brought up in the back, 3x. Okay, so first things first, what's the amplitude, everyone, as you got all your stuff ready to go? 2. What is the period, very simply? It's not 3, it is 2 pi over 3. This is all you do. And they're asking for a 2-period interval, so guess what? You're just going to do a positive and a negative. Now, as you weigh out, watch this. The non-fractionally challenged will have a good time with this. 2 pi over 3 is right there. Hey, everybody, what's half of 2 pi over 3? Hey, everybody, what's pi over 3? I was about to get the cricket that I have on my phone. Hey, everybody, what's half of pi over 3? Pi over 6. Then you ready? 1 pi over 6. 2 pi over 6. 3 pi over 6. What's 3 pi over 6? Pi over 2. And then what's 4 pi over 6? Doesn't 4 pi over 6 reduce to 2 pi over 3? Yes. Okay, and I'll do a few more. Watch the video. I have someone still standing by me here. All right, I'm talking to myself. Hold on. Okay. All right. So to break that down again, how you break this down, this is where the sine curve is going to complete. Hold on. Okay. So one more time. This is where the sine curve is now going to complete itself. So, and really, it's going to just look like this graph again, unless it's reflected. Actually, that's a bad example because that was flipped. This one, top bowl, bottom bowl. Okay, but now when you change the period, it's just the ending is different, and you're just going to note that with the value. So all your graphs are going to look very similar in your homework, and this is what you have to do, and I'll go through it one more time. The period is 2 pi over 3, so it's going to finish. We have to cut it into 4 equal parts. The easiest thing to do is to cut it in half. Now this is for the fractionally challenged. Half of 2 pi over 3 is, cancel, pi over 3. Then you cut it in half again. By the way, a half of a half is a fourth. So now you got the fourth values. So what's half of pi over 3? Again, the fractionally challenged, can't figure this out fast. And it drives me nuts all year long. And what we're saying is, and I'm going to erase this, is that is that distance, that distance, that distance, and that distance. All of those are 1/4 of the period distances. So the smartest thing to do is then, once you find this, do this fun little math. This is 1 pi over 6. Add another pi over 6, and I get 2 pi over 6. Wait for it, wait for it. Oh, that reduces the pi over 3, so I know I'm good so far. So I can add another pi over 6, and that becomes 3 pi over 6. And if you ever write that on your paper, I'm going to mark you wrong, because we always reduce. Why is he so angry? Because people do the same thing over and over and over again. They put their hand in the fire over and over and over again and get what, everybody? Burnt. Okay? Oh, I get it. It's not working out here. Okay? You enjoy my struggles on this computer. Almost getting rid of it. Well, next year. If I'm not fired. Okay. All right. So, can't say I'm going too fast. Oh, my goodness. Okay, there we go. All right. Now, we're going to get one cycle here. So, what's sine of 0? 0. All you got to remember is sine starts with 0, comma 0. And then this is the next high point. Oh, what is the high point? It's 2. That's the amplitude. Instead of 1, it's 2. And that is the new high point at pi over 6. And then I'm going to prove this. Well, I said I was going to try to make this a 5-minute video. And then this is negative 2. But I really shouldn't care. These high schoolers, they spend 84 hours on their phone in a 24-hour period. That's not even possible. But they can't even spend 6 minutes to finish the notes because, well, class is over. I have other things I got to do, like Chapsnat, TikTok, Twitter, FaceBase, MyBook. I don't even know if any of those are real anymore. All right. And then, so frustrating. And then they expect everything. And then when they don't get what they want, they have parents call. Ugh. You just cut them and paste them to the other side. And don't worry, we'll do another one and another one. Okay. And then it's not back up here. It's here because I'm not moving that negative 2. I'm tired. 0, 2, and then back to 0. Because negative pi over 6 is coterminal with pi over 2. That's not right. What am I talking about here? Okay, sine of negative pi. Well, actually, yeah, we have something. I have to plug this in. When I plug in negative pi over 6, it becomes negative pi over 2. And then that sine of negative pi over 2 is negative 1. But then it's multiplied by 2 and becomes negative 2. I went too far into it. I'm kind of explaining why this occurs. But really what you got to understand is sine. There's a sine, top bowl, bottom bowl. And then there's another cycle. What the heck? That's effective. There's another, oh my gosh. Top bowl, bottom bowl. There are 2 cycles. Okay, 2 periods. Sometimes said to be 2 cycles. Graph 2 cycles. All right, and I'll mention that when we do this. What happened to cosine? Poor little cosine doesn't get to play. Ah, you son of a. Okay, y equals. Oh, let's just say 4 because it doesn't really matter. Let's say 5. Let's say 100. Who cares? Whatever number's in front, you just put that as the top and bottom y values, and then you just say that's scaling. All right. Sine. Oh, this is a good one. You're gonna love this one. 1/4 x, unless you're fractionally challenged. Okay. Right away, just put this as 5 and negative 5. And understand that if it was a parent graph, here's 1 and negative 1. That's how cute the little cosine curve would be in this little instance. There's the parent curve. Ah, really short and flat. And okay, and maybe I'll draw that at the end. There's 1 and negative 1 compared to 5 and negative 5. Oh, but wait. So the amplitude is 5. Let's get nuts with it. Let's put a negative in front. Why is he making all these changes? Number one, you still state the amplitude as 5, but this negative is a what? Answer it to yourself. 3, 2, 1. The negative in front does what to the picture? Flips it over the x-axis. Probably too quick, and then there I go again. I just said I was going to do cosine. Schizophrenic Samuelus just can't keep his mind. Cosine. We're going to graph cosine now. But we're also going to flip it over the x-axis at the same time. So remember the attributes of cosine, flip it, but then also change the period. And actually, I'm going to go up to cosine. Here's the cosine kid, the parent. Oh boy. There it is. Oh yeah. Okay. Starts at the high point 1, goes to 0, down to the low point -1. Back to 0, then up to the high point. That's how it ends. The karate or cosine kid. But now, you know, what you're going to see tomorrow is we're just going to call this last value whatever 2 pi over b is. And then to find these values, you just hack this up into fourths, whatever it is. Okay, but anyway, oh, and then this one in my specific example is going to be flipped over the x-axis. So remember I said that. Okay, oh, wow, that was good flipping. Okay, so what's the period? It is 2 pi over a fourth. Now think about that for a minute and then tell me what the period is. 3, 2, 1. Hopefully you're playing at home. The answer should have been, oh my gosh, the old hand hitting the thing and moving my screen when I didn't ask it to. 8 pi. 8 pi. And again, I've taught you fractions all year long. For me to have to teach you that again is you're severely behind. Half of 8 pi is what? This is great. No fractions. 4 pi. Half of 4 pi is 2 pi. 2 pi, 4 pi. Anyone? 2 pi, 4 pi. 6 pi. 2, 4, 6, 8. Who do we appreciate? Not Mr. S. Not Mr. S. He yells at us all the time. All right, so what's cosine do? The cosine kid starts at the high point, but wait. It's flipped over the y-axis. So it doesn't start at the high point, it starts at the low point. It's the flipping of the cosine kid. Then goes to a 0, then goes to the high point, then goes to 0, then goes to the low point. Here is one cycle of the cosine kid. It is an upside down. And don't do this. I'm going to mark that wrong right now because that is the low point, that point. You just went past the low point. That is an illegal maneuver mathematically. Yes, illegal. They get pulled over by the mathematics police. It goes like this, all right? And then starts and continues the cycle. And that's why I'm saying the word cycle or periodic. Cosine kid just keeps going and going like this. It's like a heartbeat monitor. Kind of thing. And then we can flip it over to the other side, which I'll pause the video and you'll just see that. Okay, I just marked those values and then just understand that it's cyclical, so it keeps going and then the pattern continues, and this is true for this picture, right? So, okay, 2 cycles, 2 periods. Here's one upside down cosine kid. Here's another. Oops, and again, it doesn't hit. You see me hit it, don't you? The computer just, nope, I don't want to. Another cosine kid upside down. Upside down. There's a cosine kid, a regular one, the parent. All right? Upside down, you keep turning me. Upside down. Okay, all right. All right. This is a weird one. Do I really want to do a weird one? I don't know. Y equals. You know, the heck with them. They don't want to watch the movies. I'm going to be behind and complain. You know, forget it. Let's do a tough one. Cosine. This number doesn't even matter in front. It's such an easy thing. But let's say cosine of 7x. Whoa, that's weird. That came out of my head just. A equals 4, and it's cosine kid. The period is now 2 pi over 7. I don't even want to compare it, but what would happen compared to the parent curve, which one curve happens, one cosine kid happens to 2 pi. This one, there would be 7 complete cosine curves up to 2 pi. So this is really, really, really shrunk horizontally, like this. So that's a sine curve. But just imagine, if I did 2 pi over 7 for a period for sine instead of cosine. From here to here, there would be 7 complete sine curves that look like this. So it'd be like 1, 2, 3, 4, 5, 6, 7. It'd just be a whole bunch of sine curves all the way. So I really want you to think about that, because in your notes, or actually in your homework, all your curves are going to look relatively the same, because all you're going to do is this. Oh, I have to graph 2 cycles, one positive, one negative. Okay, I'm just going to do this again. And I'm going to end this here. And I'm going to put right here 2 pi over 7, because that's what Mr. Samuel said. Draw one cycle here, and then draw another cycle over here, up to this part. Okay, now here's our fractions. Those that are not fractionally challenged, you're going to be just fine on this. What is half? Because we want to cut this into fourths. And the easiest way to do it is just do it by half, and then half again. Half of a half is a fourth. This is the magic value right there that helps me find the third value. So what's half of 2 pi over 7? You should know it's pi over 7. And again, it does make me sad how many people are blown away by how we get that. 2 pi over 7, half of that. The 2's cancel. I'm done teaching fractions. Lexi Samuelis knows how to do that. She's a 10-year-old. All right? Half of pi. Oh, I'm laying it on thick right now. It's these frustrating things I deal with seniors leaving this glorious high school not being able to handle a fraction. Oh, I lament. Half of pi over 7 is pi over 14. Okay? Because I just said I wasn't going to do this. Just like I said, I'm not teaching factoring anymore last semester. Then I taught factoring 3 times a week. Pi over 2 times 7 is 14. All right, maybe Lexi doesn't know how to multiply fractions yet, but she will very shortly. 1 pi over 14. 2 pi over 14, because these are now pi over 14, pi over 14, pi over 14, pi over 14 away from each other. I just cut the period into fourths, and I'm leaving those shadings in there because it's hard to erase them. So back to that. 1 pi over 14, 2 pi over 14. Everyone. 3 pi over 14. You have to label these. And then is this 4 pi over 14? Well, 2 goes into both of them. Oh, be darned. That is 2 pi over 7. That's my discount double check. 1 pi over 14, 2 pi over 14, 3 pi over 14, 4 pi over 14. Get it done. Those that will be severely behind, that fail the next quiz, will still not to be able, in a week, be able to do this, breaking this down, and it baffles me. All right? 4. So easy. Just do. Do up front, and then everything takes care of itself after that. And then cut and paste these values over here. 2 cycles. All right, and then what's cosine look like? Cosine is the cosine kid. It starts at its high point, 0, low point, 0, high point. Hee-yah! And then 0, low point, 0, high point. 2 cosine curves. All right. I said we'll talk about this more. The movie is getting a little bit lengthy right now, so I'll probably do a separate movie for this one. All right, stop.